Derivatives of hyperbolic function. We have the derivative of the 6 hyperbolic functions: sine, cosine, tangent, cosecant, secant, and cotangent. The derivative of hyperbolic sine, that is equals to hyperbolic cosine. Derivative of hyperbolic cosine is equals to hyperbolic sine. I won't compare this to the regular trig function sine, cosine, and tangent. Just think about this as two sets of formula, one set for hyperbolic and then one set for the regular trigonometric function. I won't do any comparison because that will just make everything even more confusing. And then the derivative of tangent, so the derivative of hyperbolic tangent is equals to hyperbolic secant square. And then these three are the less popular. So the derivative of hyperbolic cosecant, I will just okay, everything on this page is hyperbolic. I will just keep saying the word hyperbolic a million times. So the secant derivative, that is equals to negative cosecant times cotangent, and then the derivative of secant, that is equals to negative secant times tangent. Derivative of cotangent is equals to negative cosecant square x. Of course, everything is in hyperbolic. So let's do 3 problems. Okay, let's do 3 problems so the video won't be too long. So the first one is y equals to hyperbolic sine of 4x to the third minus x squared minus cosine e to the 10x. Okay, so y prime, derivative of hyperbolic sine is hyperbolic cosine, so hyperbolic cosine, and then we don't touch this yet, so 4x to the third minus x squared, and then we do a chain rule. So for chain rule, I usually draw a dot and then you can use arrow, so that stands for chain rule. The derivative of that is 12x squared minus 2x, right? So this term is done. And then the derivative of hyperbolic cosine is equals to sine, so we have sine, don't forget the h, e to the 10x, and then for chain rule, so we draw an arrow and then a big dot, so that stands for chain rule. The derivative of e to the 10x is e to the 10x, and then one more chain rule, the derivative of 10x is equals to 10. All right, so that is for the first problem. And then the next problem, let's do some power. So let's do a k equals to hyperbolic cosine raised to the 10th power, and then we have 6x to the 5th, and then plus sine hyperbolic, and then of tangent hyperbolic, and then we have 2x minus 7 to the x power. Okay, this one I have to remind you that the cosine, so let's have a hyperbolic cosine, 10 power to the x, that is equals to, you raise the entire hyperbolic cosine to the 10th power. Okay, so you raise the whole term to the 10th power, just like the regular trig function. And then k prime, so you bring the 10th power down, and then you have a 9th power right over here, and then you have cosine h, and then 6x to the 5th. I do not recommend putting the 9 in here, because if you do, the next step, you will just take the derivative of 6x to the 5th. You will totally forget that you have to take the derivative of the hyperbolic cosine. At this point, we haven't touched the cosine yet. We just touched the power, the 10th power. Next, we have to take the derivative of hyperbolic cosine. So using chain rule, hyperbolic cosine derivative is hyperbolic sine. So we have a sine h and then 6x to the 5th. So now we took the derivative of the cosine. And then by chain rule, we take the derivative of 6x to the 5th. What is that equal to? That is equals to 30 x to the 4th power, right? And then this is done. And then we do the plus. The derivative of sine is equals to cosine, right? I mean hyperbolic, of course. So cosine hyperbolic, we have tangent, and then 2x minus 7 to the x. And then next, we take the derivative of what? We take the derivative of tangent using chain rule. The derivative of tangent is secant square. So we have secant square of everything inside, 2x minus x 7 to the x power. 7 to the x power. And then we take the derivative of this using chain rule. So the derivative of 2x is 2. The derivative of the exponential term is ln 7 times 7 to the x, and then this is the end of the second problem. A lot of chain rule, I do this on purpose. Usually the textbook problem, they are a lot easier than this. Okay, let's move on to the third problem. So the third problem, we have, what should I do for the third problem? How about let's do some ln. So how about f of x equals to ln hyperbolic sine, and then we have 12 minus 5x close parenthesis for everything, and then cosine, and then e to the x to the 20th power. So f prime of x. So ln, you have 1 divided by the whole thing. So 1 divided by hyperbolic sine, and then 12 minus 5x. And then what is next? Next, you take the derivative of sine. That gives you a cosine hyperbolic 12 minus 5x. And then you take the derivative of 12 minus 5x. That is equals to negative 5. And then you have a big minus. The derivative of cosine is equals to sine, right? So we have a sine e to the x to the 20th power, and then the derivative of e is just e. And then the derivative of x to the 20th power is 20 x to the 19. So that is the answer to the third function. And that is also the end of this video. If you like it, if you think this is how you learn, this is how you want your teachers to teach, give me a like, share the video for me. I will see you all in the next video for more hyperbolic functions. Signing out.